Now that we've identified which fields we want to bring into our database, we can go through the steps to normalize our data. The first process is to make our required fields into an unnormalized form, UNF. We list the attributes of the dataset and then identify the primary key. A primary key is a value that uniquely identifies any given record. In this case, our unique record is identified by the product order number, or PO number. Next, we identify any repeating groups in the dataset, and where we have a repeating group, we need to identify if the repeating group has a given key. This can be a single value or a composite value, which is a combination of two or more values to identify the given group. Moving on to first normal form. For the groups that we have identified, we now separate these groups from the original entity and add the original key to these new repeating entities. You can see for the entity PO Company, where we had a primary key of the company name, to relate this back to our original product order, we add the field PO number to the company entity. And similarly, we do the same for PO Vendor, PO Ship, and PO Item by adding the PO number to each of the new entities. This ensures that we now have a relationship between the original product order and our new entity groups. Moving on to second normal form. First, we examine the tables for composite keys, i.e., a key made up of two or more parts. For each non-key attribute, we then determine if its key is the first part, the second part, or neither. If neither, then we use both parts. Lastly, we remove the partial key and its dependents to form a new table. If we now review our diagram on the left, we can see where we had a relationship for PO Company and product order. We can now separate out company into its own table, dim company, which will act as a lookup table for PO Company by reference of the company name. By creating dim company, this ensures that we only have a single source of truth on record for any given company. We do similar with dim vendor, dim ship to, and dim item. Such lookup reference tables are often referred to as dimensional tables, and hence common naming convention is to prefix such tables with the abbreviation dim for dimension. For third normal form, we need to identify any dependencies between non-key attributes with each table. We then remove these dependencies and create a new table. We then promote one of the attributes in the new table to be a key for the table, and lastly we can take the new key value and link it back to our original table, which will be known as a foreign key in our original table. Reviewing our diagram, we can now see that a number of new relational tables have been created, which identify relationships between the original product order and a dimensional table. For example, in the product order table, the field authorizer has been replaced with the company employee ID from our dim company employee table. We can do similar for dim vendor employee, where the requester of the product order has now been replaced with the vendor employee ID. Once we have reached a third normal form, we can now review what indexes have been created. If I find the index is made up of a character or string value, then I will typically replace this value with a numeric field. For example, dim company, the primary key was the company name. I've now added a new numeric value called company ID. Company ID can be automatically generated in our database or by our source program, and would typically follow the form of a value which is incremented by 1. Therefore, any time we have a new company added to our table, the company ID will be set automatically, which will be a value corresponding to the maximum company ID in the dim company table, incremented by 1. Using a numeric value that is automatically generated for us also ensures that we can't have an index violation where we may actually have two company names with the same name. This case is quite common where a global company may have multiple offices under the one company name. For example, suppose our company WhatData has a number of global offices. If we use the company name as an index, this will cause an index violation, as an index is to provide a unique identifier for all records. Instead, by using a primary key that is automatically generated for us, the company name can remain the same and we don't have an index violation. Each row is now uniquely identified by the company ID. In addition, we may want to also record which account is the master account for WhatData by adding a master company ID field. If the master company ID equals the company ID, this informs us that the master account, all subsequent accounts, can be placed under the master account by making reference to the company ID. In our example, we have a company ID equal to 1, which we will set as the master company ID, and company IDs for 2, 3, and 4 are child accounts of the master company ID equal to 1. This structure will also allow for creating hierarchies of many levels, provided a company ID is assigned to a master company ID. To summarize, in third normal form, there should be no scenarios where we have two entities sharing the same table. And any time where you see such a group of information, you can typically separate this out into a separate entity table and provide a foreign key lookup back to the original table. This reduces the amount of data that needs to be stored in a table, hence removing data redundancy. While we have normalized our data to third normal form, it is always good to check that our data, indexes, foreign key, and new dimensional tables all make sense to our project. That concludes this section on data normalization.